Hi, let's look at friction in this video. What is static friction and how does it act on objects? Let's look at this block lying here on the floor and I apply a force to this block in this direction, force F, a very gentle force. Initially, the block doesn't move and then let's say I apply F1, there is no movement. I slightly increase F1 to F2, still there is no movement. And then I increase it to F and then it starts moving. So what was preventing this block from moving when I applied F1 and F2? There is some opposing force that is preventing the block from moving, and that comes from the contact of both the surfaces of the block and the floor. That is called friction. And we represent this as F sub S, which is nothing but static friction. S stands for static friction. So this force which prevents the block from moving is called the frictional force. But interestingly, this frictional force doesn't depend on the area of contact. How much area of the block is in contact with the surface of the floor? No, it doesn't depend on the area of the contact. It only depends on the normal force exerted by the floor on the block, which is N. So it can be given as, we can say that this force, static frictional force, the maximum force that I applied, the opposing force is equal to the force at which exactly it started moving that instant. That is the maximum frictional force. That is the frictional force that was acting when I applied F1 also, when I applied F2 also. But the frictional force when I applied F is the max frictional force. So that frictional force, we can call it Fs maximum, is given by the product of mu s and n. N we know is the normal force, but what is mu s? Mu s is called the coefficient of static friction. Coefficient of static friction is mu s. So this is the formula for force due to static friction. Okay, now let's call this case A and let's take another case B, where the block of mass m is placed inside a moving trolley. The trolley is moving in the direction shown by the arrow. And let's see what happens here. Assume that there is no friction, absolutely no friction, if mu s equals 0 between the block surface and the trolley surface. As the trolley moves forward, nothing opposes the block M, and eventually the block will move backward and hit the back wall of the trolley. Assume that there is an ice floor inside the trolley and a smooth block, is wooden block or a metal block, is placed on the ice floor. So, because there is no friction or negligible friction, as the trolley moves forward, the block will slide and hit the back wall of the trolley. Which means if I give some opposing force and stop the trolley from moving, then there are two things that happen. First is, relative to the trolley, the block is at rest, right? If I give an opposing force, namely friction, if there is a friction between the block surface and the trolley surface and the friction opposes the movement backward, then eventually what happens is the block remains at rest relative to the trolley. Relative to the trolley means trolley is moving from inside the trolley. If you observe, when there is friction, the block will be at rest. So it's at rest relative to the trolley. But if there is no friction, as we saw in this case, then it is moving relative to the trolley. If there is no friction, it's moving inside, from inside the trolley. If you observe, the block will slide back and hit. So in both cases, if you see, friction makes a change in the relative motion only. Relative to the trolley, it affects the movement of the body. So friction acts on the relative force, relative motion of the block. Now let's try and figure out what this acceleration can be of the trolley maximum. See, because as the trolley accelerates forward in this direction, if there is a friction, if mu s has a value, then depending on the coefficient of friction, only a maximum acceleration is allowed, which means, let's say if the acceleration is a1 and there is a friction between the block and the surface of the trolley, and there is an acceleration of a1 of the trolley, then the block doesn't move backward. Then it increases to a2. still the block doesn't move backward. But at some acceleration a, the trolley will move forward with such velocity that the block will start sliding backward. What is this maximum acceleration possible? Is it possible to figure that out? Let's find out. We know that the block inside the trolley doesn't move backward to a maximum extent as opposed by the maximum frictional force, which means mu s times n is the maximum frictional force, and that gives m times acceleration max. Ma is the force, Newton's second law, so m times a max equals mu s times n, which is the maximum frictional force, equals force also given by this formula, which is ma. And we know that mu s times n is nothing but mu s times mg. N can be written as mg because n is nothing but the normal force, which is equal to the weight of the block of mass m. Now, if we take only these two portions, m cancels out, and a max is given by mu g. That means the maximum acceleration of the trolley without the block sliding backward is given by mu s times g. That means higher the coefficient of g is always a constant, it's not going to change. So higher the coefficient of friction, the more the trolley can accelerate without the block sliding backward, which makes sense, right? Okay, thank you.